Hello dear friend, this is Himmet. In this lecture we introduce volume of solid of revolution. Actually, to find the volume of a solid of revolution, we have two methods. First one is volume with the disk method. Second one is volume with the shell method. Let's consider firstly the first method, which is volume with the disk method. Okay, now the volume of the solid obtained by rotating the region bounded by the curve F and the line A and B and x-axis about the x-axis is yx is pi times from integral from A to B f square of x dx, which is pi times integral from A to B y square dx. Okay, now we call this x-axis axis of revolution or axis of rotation if this region is rotated about the x-axis, then we have a solid of revolution. And then in this lecture we would like to calculate volume of a solid of revolution. If we have two curves F and G, and then our formula can be like this, which is the volume of solid obtained by rotating the region bounded by the curve F and G and the lines A and B about the x-axis is yx is pi times integral from A to B absolute value f square minus g square dx. You can see that x is horizontal axis of rotation, and then if you look at all these explanation carefully, you can see that in the disk method everything is suitable with the others, which means that our function depends on the variable x, and our axis of rotation is x-axis, and then our lines depends on, again, x is A and x is B. And then similarly, I think we can give the following remark: the above formula can be rewritten in terms of the variable y. Right? Now, our second method is shell method. Volume with the shell method. The volume of the solid obtained by the rotating the region bounded by the curve F and G and lines A and B about the x-axis is defined by this formula, which is y is 2 pi times integral from A to B absolute value of x times f minus g dx. This y is our vertical axis of rotation. Now if we take y which is g is 0, then this means that we have x-axis, and so this formula turns into such a formula, which is volume in terms of y-axis is 2 pi integral from a to b absolute value of x times f dx. In the first method, we can formulate these two formula again in terms of the variable y. As you can see that in the shell method, we have opposite situation. That is, while the axis of rotation is the y-axis, then all the other things must be dependent on the variable x. As you can see that this is y is our axis of rotation, but if you can see that our function is depends on our function, or our curve r depends on the variable x, and our lines again depends on the variable x. But our axis of rotation is y-axis. Right? Now, to understand all these theoretical things, I think we can give some example. The first example is, please find the volume of solid obtained by rotating the region bounded by the curve y is 15x squared plus 1, and the lines x is minus 1 and x is 1, and the x-axis about the x-axis. As you can see that our curve depends on the variable x, and our lines again depends on x, and rotate axis of rotation is again x-axis. As you can see that everything is suitable with the other, so that I think we can use to find the volume, we can use the disk method. Now, right, let's look at what happened. This is our curve. Y is 15 times x squared plus 1, line minus 1, and line 1, x-axis. This is our region. This region is rotating about the x-axis, and so then I think we have such a solid of revolution, right? And then volume of the solid is depends on the variable x. This is our axis of rotation, and then pi times integral minus 1 to 1 y square dx. Okay, now I think pi minus 1 to 1. What is our y square? 15 times x square plus 1 square dx. If you calculate this integral, then you will have 112 cubic units. Okay, 112 cubic units. Right, let's look at second example. Second example is find the volume of the solid obtained by rotating about the y-axis the region between the curve y is x square and y square is x. Okay, now as you can see that we don't have the limit of integration, and then we have just two function and axis of rotation, which is y-axis. That's all. I think we can use these two methods together. First way, disk method. Okay, let's use firstly disk method, and then this is our x is y square. This is our another curve. X is y square. Okay, this is our region. This region is rotated about the y axis. Okay, this is our y-axis. Right, if this region is rotated y-axis, then we have, I think, such a solid. Okay, I think we have such a solid, but be careful, here is empty. Okay, right, and then the first method, which is this method, give us yx is y sorry y is, because this is our axis of rotation is y-axis, and so in this method everything is suitable with the others, and so as you can see that we have two functions. First one, y is x square. Second one, x is y square. And then everything must be dependent on y square. Y, x is square root of y. Let's call f of y, and this is g of y. And then about the y-axis. Okay, now I think everything is ready. Pi times integral f square minus g square of y dy. Okay, right. Pi times integral. What is f square y minus what is g square y to the 4 dx y dy. Now we have to calculate this integral. As you can see that this integral depends on the absolute value, and then we have to remove this absolute value. We know how to behave such an integral as we did in finding the area in Cartesian coordinate system. We don't need the integration limits in the first step, and then to find the limit of integration, let's look at inside of the absolute value. Absolute value is say 0, and then y times 1 minus y cube is 0, and then root of this polynomial y is 0 and y is 1, right? And then the the lower limit of the integral is 0. The upper limit of the integral is 1, and so the second step is we have to look at the sign of the absolute inside of the absolute value, right? Y minus y to the 4. Our root, first root is 0 and second root is 1. The sign of this is polynomial, sign of y to the 4 is minus, plus, minus, between 0, the sign between the 1 and 0 and 1 is positive, and so inside of the absolute value is positive, and then I think we have integral from 0 to 1 y minus y to the 4 dy, and then we have 3 times pi over 10 cubic units. Okay, the volume is 3 times pi over 10 cubic units. Right, now this is first way. The second way is shell method. Okay, what is shell method? Shell method, in the shell method we must have opposite situation, right? That is, y the axis of rotation is the y-axis, all the other things must be dependent on the variable x. As you can see that we cannot change the y-axis, but we can change the variable of the given function, and so y x square, this is our function f of x, x is y square, and then y is square root of x, which is g of x, and y axis. As you can see that our two function depends on the variable x, but axis of rotation is the y-axis, which means that we have an opposite situation. Okay, now this is our shell method, and then y is 2 pi times integral x times f minus g dx. Okay, 2 pi integral absolute value of x times, what is f? F is x square minus what is g? G is square root of x dx. Okay, right. 2 pi integral x cube minus x to the 3 over 2 dx. Now we need to calculate this integral again, as we did in finding the area in Cartesian coordinate system, and we don't need the limit of integration. First step, let's find similar way as in the finding the area limit of integration. The inside of absolute value x cube minus x to the 3 over 3, 2 is 0, and then we have x is 0 and x is 1, and so this is our lower limit 0, this is our upper limit 1, and so we need the second, as a second step, we need the sign of inside of the absolute value x cube minus x to the 3 over 2. First root is 0, second root is 1. The sign of x cube is positive, negative, and positive. As you can see that the sign of inside of the absolute value is negative, and so negative less than 0, which means that minus, let's put minus 2 pi integral from 0 to 1 x cube minus x to the 3 over 2 dx, and then we have 3 times pi over 10 cubic units. Okay, this is our value. The third example is the volume of the solid obtained by the ellipse about the x-axis. Now, let's look at this example. Find the volume of the solid obtained by rotating the region bounded by the graph of the ellipse. The formula is about the x-axis. Now, the graph of the ellipse is given by like this. Okay, say here A minus A and B here minus B. Okay, now axis of rotation is the x-axis, and so this is our axis of rotation is x-axis, and then 0 is our origin. Then we have such a, I think, solid, right? Solid. We have such a solid, right? And then I think we can use disk method, and then dx is pi times integral from 0 to a y square dx. Okay, as you can see that integration limit is here from 0 to a. At that time we have calculate just this part of the solid, but total volume, to find the total volume of the solid, we have multiply this integral by 2, and then we have total volume of the solid. Okay, right. Now I think from this formula we need to take y square. I think y square is b square times 1 minus x square over a square. All right, let's write here 2 pi integral from 0 to a b square over a square, a square minus x square dx. Right, if you calculate this integral, you will find that 4 over 3 times pi times a b square cubic units. Right, this is our volume of the solid. If you take a and b is r, then you will find that the volume of the sphere of radius r is 4 over 3 times pi r cube cubic units, right? I think that's all. Thank you.